Hello, welcome again to Analog Output, and happy April Fool's Day. I'm not going to play any jokes on you. Unless that was a joke I just played on you. I'm going to talk about March, because in March I did a bunch of electronics projects, about 6 of them, and I talked about one of them, the ribbon controller interface, which I completed early in March. None of the others I really wanted to do a whole video about, so I thought I'd do a whole video about all of them. Okay, so this is how I spent my month of March. Besides the ribbon controller, the next thing I did was this. I made a cigar box. No, I did not make a cigar box. I made something and I put it in a cigar box, and what I made is this. Okay, this is the Mutable Instruments module tester. This is something that Mutable Instruments had on the market for a number of years. They no longer produce it, but it is open source hardware and open source firmware for this chunky guy over here, and you can download it, you can fabricate the PC boards, you can put it together, you can flash the firmware, and there you go. I actually did a little bit of modification. One thing was I decided I wanted to use this lovely cigar box picture of celebrated Danish navigator, discovered Bering Strait, Vitus Bering, there it is. Anyway, decided I wanted to use that cigar box, so I made the circuit board a little bit larger, enlarged it a little bit so it fit snugly inside the box. This thing's actually not fastened down in any particular way. It's just kind of shoved in there on top of a couple of spacers. I'm intending to do a better job mounting it in the box at a later date, but for now it's just kind of sitting there. Got a couple ports on the back and power cable on the front. Anyway, what is it? It's a device for testing and breadboarding and calibrating synthesizer modules. So it has several jacks here. It's got 4 output jacks. This is a clock output, a gate output, a control voltage output, and an audio output. And these will put out various clocks and gates and control voltages and audios and so forth. Depending on what you set up using a menu system with this liquid crystal display and this rotary encoder here. And then there's 2 input jacks. There's an audio in and a gate in, where you can plug in audio and gate signals and get some diagnostics for them up here on this screen. And there's a MIDI input in the back that I mentioned, and audio output so you can actually listen to the signals that you're working with. This is the power jack over here, and you can use this to power the module that you're working with. And it's pretty handy, and especially so if you are building one of these. Okay? Helps if I show it right side up. Let's do another take of that. It's pretty handy, especially if you're doing one of these. This is a voltage-controlled oscillator, and like any voltage-controlled oscillator, when you build it, you need to calibrate it, and calibrating it is usually a kind of a tedious thing where you have to feed it one voltage and then another voltage an octave or 2 octaves higher, and then you measure the frequency at the 2 voltages, and you compare the 2 frequencies, and you see if one's twice the other or 4 times the other. And if they're not, you turn a screwdriver and twiddle a trimmer, and you turn it the wrong way and discover you're going in the wrong direction. So you turn it the other way, and then you go back to the first voltage, and you go to the second voltage, and you read the frequencies, and you calculate them to see if one's twice the other, and you see how much closer you're getting or further away, and you turn the trimmer some more, and you go back to the first voltage and measure the frequency, the second voltage, you measure the frequency. It's a pain in the butt. With this thing, it gets a lot easier because you can set it up so the control voltage output here is feeding out two voltages. I think it's 1 volt and 3 volts. Maybe it's 0 volts and 2 volts. Anyway, two control voltages that are 2 volts apart, just back and forth between them, about 5 seconds on each. You can change that. And then you can take that, put it in your control voltage input on your VCO, take your audio output and put it into the audio input here, and you can put it in a mode where it will display the pitch difference between the current pitch and the previous one. And it will do that in cents, which is, a cent is 1/1200th of an octave. So if you're putting in two pitches that are 2 octaves apart, it'll display 2400. If it's displaying 2430, you need to turn your screw down in one direction. If it's displaying 2380, you have to turn it the other direction, and you just, twiddle your trimmers until you're getting 2400, and that's it. It doesn't turn the trimmers for you. You still have to do that, but other than that, it takes care of everything, and it is great. It just made it so much easier to calibrate this thing, which is, as I said, a VCO. And I am going to tell you all about this VCO in detail in an upcoming video, but this is actually part of another sort of a larger project, and I want to complete the rest of the project before I talk about the whole thing. And you may notice we're having some component shortages. There's one part that I can't get at a price that I'm willing to pay for the next part of this, so I'm going to have to wait until that part is more readily available. So you'll have to wait until that to hear much about this. Anyway, it's a voltage-controlled oscillator. It's got kind of the features you'd expect. You might not expect an 11-position octave switch, but, well, there you go. Let's see, what else do we have from the month of March? We have this. This is an ADSR envelope generator. It's exactly like the ADSR envelope generator I showed you earlier. I just made another one. Big deal. Okay, what else? There's this. This is attenuverters. If you don't know what an attenuverter is, do you know what an attenuator is? An attenuator, you put in a signal, and if the slider's at the bottom, you get nothing out. If the slider's at the top, you get the full signal out. It changes the amount of the signal you get out. With an attenuverter, it does the same thing, except in the middle, it gives you nothing out. As you turn it up, it gives you more and more of the signal, and as you turn it down, it gives you more and more of the signal inverted. So if you're putting in 5 volts, then here you're getting nothing out. Here you're getting 1 volt, 2 volt, 3 volt, 4 volt, 5 volt, and here you're getting -1, -2, -3, -4, -5. So it attenuates and inverts signals. There's 3 channels for 3 signals, 3 outputs. There's also 2 outputs for the sum of the 3 signals and the inverted sum of the 3 signals. There's a switch here that lets you change this so that instead of looking at what you're putting into that jack there, it's looking at a 10 volt signal. So then you can just dial up any DC voltage you want from plus 10 volts to minus 10 volts here. Pretty simple module, pretty basic, pretty useful. And what else? Last item we've got here is weirdest. This is an infrared input module. This is based on a design from Barton Musical Circuits. You can order the circuit board from Michael Barton's website, but I decided to build this with some modifications. Let me tell you just in brief about what this is about, but you should follow the link down there and you should go look at the demo video that he recorded. It's quite entertaining. I looked at that video and said, need one of them. Anyway, what it is there's a phototransistor here, an infrared phototransistor, and infrared radiation falling on this produces a signal. This amplifies it, sends that signal to the output. You can have that AC coupled or DC coupled. So DC coupling, you're looking at the whole signal. AC coupling, you're just looking at the fluctuations on top of the steady state signal. There's a sensitivity knob, so you can dial in how strong a signal the the phototransistor is sensitive to. There's a threshold knob so that whenever the output goes above the threshold that you set here, it produces a gate. What I added here was a third knob. This is a gain knob, which changes the gain on the input stage after the phototransistor. The idea being that, especially if you're in AC mode, this is useful because you might have a large signal with small fluctuations on it. And when you're in AC mode, you can't turn the sensitivity up too far because the signal's big, but you don't get very much variation in the signal because the fluctuations are small. So you turn up the gain instead, and that amplifies those fluctuations. I also added a couple more LEDs. This LED was part of the original design. Tells you when the gate comes on and off. I added this bicolor LED, which tells you what the control voltage output is doing. Bicolor because in AC mode it might be positive or negative. In DC mode it'll always be positive. And I added this one, which is an indicator for when the phototransistor is near saturation. So if this light is lighting up constantly, you probably need to turn the sensitivity down. But you probably want to operate where it's sort of just below where the red light is coming on all the time. And one other thing, if you look in Barton's video, you see how he uses this to make a flame-controlled synthesizer. You can take a lighter or a candle or something like that and make varying control voltages by, waving around your lighter or just by the flickering of the candle, whatever. You might, though, be thinking, well, it's kind of not a great idea to have an open flame sitting a few inches in front of your synthesizer, especially if you're trying to, adjust the patches at the same time. And you'd probably be right about that, which is why I added this. So this is a phototransistor on the end of a cable, and there's just a switch here that lets you select between this phototransistor or this one, so you can set up your flame over here and your synthesizer over there and be a little bit more sane about what you're doing. Anyway, yeah, that's it. That's what I've been doing for the month of March, in addition to doing some designing and thinking about future modules and so forth and so on, which you can hear about if you, hit the subscribe button and like and, all that crap. So do that, and I'll see you next time on Analog Output.